Hey guys, this is PreAP Chemistry Solutions number 2. So let's get started. All right, so first, what is a dilution? Well, a dilution is when a solution of a particular concentration gets solvent added to it. And so what that does is it ends up diluting the concentration of that solution to a lower concentration. All right, so if I have this right here, and let's say that I put some of that into another beaker. So let's say this beaker is also 1 liter. So I'm going to put some of this into here, and we're just going to count these. 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 molar solution because there's 8 moles. We're going to count every dot as a mole, even though that's not right. We're going to count every dot as a mole. So there's 8 moles per liter in here. And we're going to fill this up halfway. So it'll be halfway filled. And this solution would still be 8 moles per liter, but I've only got half a liter. So that would mean I would have 1, 2, 3, 4 moles. So we have 4 moles in 0.5 liters. So that would be 8 molar. So the concentration of the solution is still 8 molar. I haven't diluted it. All right. Now, if I add 500 milliliters of water to this, okay, and these start to move around in here, so they would spread apart a little bit, then I wouldn't have 4 moles in 0.5 liters. I would have 4 moles in 1 liter. And so I've effectively diluted this solution from 8 molar to then 4 molar. Okay, so looking up here at this picture on the top right, over here we have a very concentrated solution. The color is very dark, and down here it's really diluted. So we've taken a little bit out of this, put it into this cup, added some water. Taken a little bit out of the second cup, put it into this cup, added some water. Taken a little bit out of this one, added it to this cup, and added a little bit of water, and so on and so forth, and it's called a serial dilution. I'm not so concerned about that, but I just wanted to give you something that you could see that might look familiar, something like maybe Kool-Aid that's been diluted several times. All right, so how much of a 12 molar HCl solution would be needed to produce 1,750 milliliters of a 0.3 molar HCl solution? So on the previous slide, I kind of started to run out of room, but the dilutions can follow an equation. So for dilutions, you can use something called the dilution equation. And the dilution equation is M1V1 is equal to M2V2. So all you have to do is plug them into the right side, in the right place, in the equation, and you'll be okay. Now, it doesn't matter which one you use for M1 or M2, as long as it's with the right volume. So when this says 1,750 milliliters of 0.3, those two things have to go together. So you have to make sure that if you call this M2, then this is V2, if that makes sense. So let's try using this equation with this first example. I'm going to say that this is M1, this would be V2, and this would be M2, because these have to go together. And I want to know how much of this solution, so that would be my V1, is what I'm looking for. So I'm going to plug everything into the equation. There's M1. I'm looking for V1. M2 is going to be 0.3, and V2 is going to be 1,750. So then I'm going to solve for my unknown, and V1 ends up being 43.75 milliliters. And since we have 2 sig figs, that would be 44 milliliters. Okay, as far as liters and milliliters go, You can use whichever unit you want as long as it's the same on both sides. So if you put milliliters in this side, you have to have milliliters on this side. If you put liters into one side, you have to put liters in the other side. So what this basically says in this problem is that we're going to take 44 milliliters of this 12 molar solution and we're going to add water to it until we get to 0.3 molar. And we're going to have 1,750 milliliters of that. So that means that we're going to have to add 1,706 milliliters of water. About, roughly. There is a little bit of a volume change, but we're not going to talk about that. All right, number 2. What is the concentration of the resulting KMnO4 solution when 287 milliliters of a 1.5 molar solution is diluted, keyword diluted, so that I know I have to use this equation, to a total volume of 600. So I have 287 milliliters, so I'm going to call this V1, this would be M1, and this would be V2, and I'm looking for M2. So I'm going to divide both sides by 600. So my M2 is 0.718. So we basically took 287 milliliters of a 1.5 molar solution and we added to that just over 300 milliliters of water because we had 287 milliliters of this and we ended up with 600 milliliters. So the only way to do that with a dilution is to add the difference in water. And that's why the concentration went down so much. How would you prepare 1 liter of a 2 molar solution of NaOH from 8 molar solution NaOH solution? This is a how question. So with how questions, you have to answer it with a sentence. So how would you prepare 1 liter of a 2 molar solution from 8 molar NaOH solution? So I'm going to call this M2 because we still have to solve it. So this would be M1 and this would be V1. So I'm looking for V2. So it's going to be 2 divided by 8. So that's just the math side of this question. It says, how would you? So I'm going to take 0.25 liters of 8 molar, because M2 and V2 are connected with the word of, solution, and dilute it to a total volume of 1 liter. And so we would add about 0.75 liters, and you could say that instead, but really, as long as you get to a total volume of 1 liter, that can be inferred. Because it might be a little bit less, especially with sodium hydroxide, but we're not going to get into the whys of that. All right, adding solutions together. What would happen if we added 2 solutions together that had different concentrations? In this scenario, we're taking a solution that has something like this, and we're going to add it to something like this. So that means that the concentration of the resulting solution after they're mixed should be in the middle of whatever they started at. So after they're mixed, the concentration will be somewhere between the lower solution and the higher solution. All right, what would the resulting concentration be if 250 milliliters of a 5 molar HCl solution was mixed with 250 milliliters of a 10 molar solution of HCl? So the first thing I'm going to do is I'm going to find the number of moles here, and I'm going to find the number of moles here. So I have 250 milliliters which is 0.250 liters. We're going to divide it by 1,000 because there's 1,000 milliliters in a liter. And this would also be 0.250 liters. So I'm going to take 0.25 liters times 5 moles per liter of HCl. So that would be 1.25 moles. So that's the first one. Now the second one, I have 0.25 liters in a 10 molar solution of HCl. So that would be 2.5 moles. So we're going to mix both of these together. So that means I would have 3.75 moles all together. So what would my volume be all together? Well, I have 0.25 liters here and I have 0.25 liters here. So all together, I have 0.5 liters altogether. So that is going to give me 7.5 molar, because I take the moles and I divide by the liters to get molarity. All right, what would the resulting concentration be if 1.25 liters of a 2 molar NaOH solution was added to 200 milliliters of a 3.5 molar solution? So this one, I'm also going to find the number of moles in each one. So in my first solution, I'm going to have 2.5 moles. And then in my second one, the 200 milliliters has to be turned into liters. And so that's 0.7 moles. So altogether, we have 3.2 moles. And then the volume altogether is 1.45. So my molarity is going to be 2.2. So really all you're doing is you're finding the moles of each of the solutions, taking the liters of each of the solutions, adding them together, and then dividing the total moles by the total liters. All right, and one thing I want to point out before we're finished here, because we're almost done, is I have 7.5 molar of my resulting solution here, whereas I started with 10 up here and I started with 5 up here. And 7.5 is right between 5 and 10 because we had equal amounts of both of those solutions, so it only makes sense that it would find the average there. In this one, I have 1.25 liters and 200 milliliters. So my resulting solution is going to be a lot closer to 2 molar than it would be to 3.5 molar because I used way more of this. I used 1,250 milliliters of 2 molar and I only used 200 milliliters of 3.5 molar. So it's much closer to 2 than 3.5 because I used more 2. So I hope that makes sense for everybody. Please let me know if you have any questions. I know that this can get confusing. Good luck.